Okay, so the first thing that happens here is I see that cube, and that is actually going to be a key to me that I'm going to do the sum or difference of cubes. The 40 and 625 are not sum and differences of cubes, but I know that a 5 can go into both of them. So if I pull a 5 out, I end up with 8v cubed minus 125. And I know that these are both perfect cubes, so I know that A is 2v times 2v times 2v, and B is 5 times 5 times 5. So then I do, it's the difference of cubes, so I do 2v minus 5, and then I square that 2v. 2v times 2v is 4v squared. Change this sign, multiply them together, the A and the B, and then square the last. Okay, this will never end up being a perfect trinomial square, so you are actually completely done factoring right there. In 18, I'm going to end up grouping, and the first group I can take out of 4, m squared, oops, leaving me m plus 3. And I can take out a negative 9, leaving me m plus 3. They match, so I'm going to pull that out. And what's left? Okay, you should recognize this as the difference of squares. So I'm going to have m plus 3. 4m squared is 2m times 2m. 9 is 3 times 3, 1 plus, 1 minus. Now, if you don't remember that, you're missing the middle term, so you really could rewrite it like this and do the whole multiplying, find the pair that adds to 0, but the pattern is way more easy than doing all that work. Okay, number 19, I'm going to multiply my a times c, and I'm going to get negative 24, and I'm going to list all the 24s. All 4 of them. I'm looking for the pair that will give me 5. So I know that's a negative 8 and a positive 3. Added, they will give me the negative 5, and multiplied, they will give me the negative 24. So I'm going to split the middle. Oops, this needs to be cubed minus 8y cubed minus 4. Don't forget, these two middle terms need to add up to this middle term. So whatever variable this has, these must also take on. I'm now going to group, and the first group has a 3y cubed times 2y cubed plus 1. And the second group has a negative 4, leaving 2y cubed plus 1. They match. And looking at it, I see this, and it should tell me, look for sum and differences of cubes, but I know 3 isn't a perfect cube, and I know 2 isn't a perfect cube, so I'm done. Okay, so we're doing a planter. It tells me that my length, width, and height need to be as indicated. The sides are 1 foot thick. The planter is on the sidewalk. It does not need a bottom, and it's to hold 4 cubic feet of dirt. So since I'm given the volume of the inside, I need to work with the inside, so I need to figure out what that dimension, what that dimension, and what that dimension are. Well, this side would be 6x minus 2 because I have a foot on either side. This side would be 3x minus 2 because I have a foot on either side. The height is going to be just plain x because it tells me I don't have a bottom. So if I multiply those all together, which would be volume, that has to equal to 4. Now let's talk about y equals. I need to set this equal to 0, so I'm going to subtract that 4 over. I'm not doing any multiplying. And I would then put that in y1. If you think about what the graph of this is going to look like, let's just assume no idea what it's going to look like. It's going to look like this. I don't care what those two solutions are, because if I plug a 0 or a negative in here, I have no height. I'm only looking on my calculator for that one, so I'm going to second trace the 0. Now, if we were going to solve it by hand, we would multiply that all out. If we multiplied that all out, we'd end up with 18x cubed minus 18x squared plus 4x minus 4 equals 0, because I'm going to subtract that over there. I can now group this. I can take out 18x squared here and take out 4 here. They match. You should start being able to see that this is going to give me imaginary results. That's an x squared. I'm going to subtract that over. As soon as I think about taking a square root, I'm going to be taking a square root of a negative. So this one can't give me a solution. My solution is going to be 1. So the outer dimension should be 6, 3, and 1.